Okay. Do you all see the question? Did you see it? Yeah? Do you have that?
Yes.
Angela? Okay. Right. Oh, you know our class is later today at 3. Yeah. Okay, so you have, this is your curve. Right, first part, find the derivative for 2 marks. That's nice to get us started, isn't it? dy dx equals 72 x squared minus 72 x cubed. Is that right? Goodness, I hope so. Hey, Michelle, are you feeling better? You were out last week, weren't you? Not all the way better yet. Oh, no, no problem. No problem. I was just saying that I uploaded newer exams. I have 17/18's exam on Moodle. So we're having a look at version 2 on 17/18. Oh, yeah. Can you log in? No. Here. You'll have to sit beside someone, actually. Okay, is that okay for this part? Yep. So, B. Find the stationary points. Okay, so that means 72x squared minus 72x cubed equals 0. So if I take out 72x squared, I'm left with 1 minus x equals 0. So I get x equals 0 or x equals 1. Now, C. Can I scroll down? Now, this is where, do you remember that page I gave you a couple of weeks ago? Do you remember that page I gave you?
Yeah.
Yeah? Do you still have that page?
Yeah.
Do you know the page I gave you with the flow chart on it? You like go left, right, down. I think it'd be great if you could take that out. That one. It took me ages to make that in Microsoft Paint. It's a work of art. You want a copy of that? I can make it for you. You have it? Yeah. If you need me to print out a copy of that flow chart, I can.
Yeah, I'll let you know.
Confirm that there's a point of inflection and determine whether there's a maximum or a minimum. So you have the flow chart there. For point of inflection, you need the second derivative to be 0. And the first derivative, it would be nice if it wasn't 0, then that means it's a point of inflection. So this is what you would love to have. You would love the first derivative to not be 0 and the second derivative to be 0. This makes the inflection point. By the way, what makes the stationary point? The turning point. dy dx is 0 and the second derivative, you would like it to be not 0. Because remember I said if both of them are 0, then it becomes a little bit messy. But I give you a flow chart to help you out. So let's see what happens here for this one. Let's get the second derivative now. Well, actually, do you know what? Yeah, we need the second derivative. The second derivative is 144x minus 216x squared. Now, what happens if we put in 0 here for x? Because they tell us, confirm there's a point of inflection at 0. What happens if we put in 0 here? What do we get? 0. This is when x is 0. Now, this is a problem, because we know from the previous part that if you make x equal to 0, the first derivative is 0. So, this is also the same problem when, oh no, it's not a problem when x is 1. Okay. Anyways, what does it say to do if you follow the flowchart? The first derivative is 0 and the second derivative is 0. What do I need to do next? Differentiate again. And I get 144 minus 432x. Now, if I put x equal to 0 here, what do I get? Positive, negative, or 0? Positive. So, what happens if it's positive? Yeah, what's it called? Like, give it a name. Are you sure? I don't think it's that. I think you're misreading the flowchart. Increase in inflection, I think it is. So therefore, increase in inflection. It's like this. Yeah? Now, we have to do what happens at 1. So what happens if I put in 1 into the second derivative? I'll get a positive, a negative, or 0. If I put in x equals 1, what do I get? Negative. Okay, so back to the flowchart. The first derivative is 0 and the second derivative is negative. That should be a max, isn't it? Now you see, that's nice for 5 marks, but you won't have the flowchart in the exam. But if you remember your flowchart, you can do this 5-mark question pretty quickly. The alternative way to do it is by actually sketching the graph at 0 and 1 by collecting a few points nearby. That's why they were imagining 5 marks for this, because they were picturing 99% of students to gather a few points near 0 and 1 and to make the graph and judge from the graph. You understand why it's 5 marks? And also, 5 marks is fair enough because you have to remember that flowchart. It's not easy to remember, right? I mean, it's not even easy to read. So 5 marks actually is fair enough. Now, D, the sketch. Sketch the curve. This must not be done on graph paper. Showing clearly all the coordinates. Okay. Oh, sorry, do you have this written down, Ahmed? It is a bit odd, isn't it? Because the alternative method is to graph it, which is exactly what they ask you to do in D. So you might as well do D before C. So the marking is very strange here. It's very strange. This is an example where it's easier to do the question out of order. It doesn't happen so much in maths. It happens sometimes in physics where you look ahead of what you're to do next and you realise, oh, it actually will be a little bit easier if I do B first because the answer there can help me in A. It's actually fine to do it out of order as long as you clearly mark it. Okay? So yeah, if you wanted to do the graph first, would have made sense. Can I scroll down? Yeah. I need to actually, before I do that, put 0 and 1 into this to get the coordinates. So,
Sir,
yeah.
I wanted to ask whether trigonometric graphs are very common.
No. Well, they come up the odd time, but they're not as common as cubics or these types for sketching. What happens if I put in 1? 24 minus 18 is 6. 6 plus 8 is 14, isn't it? Is that right? 114? Yeah? Are those points correct? I think so, right? Now, let's draw. Okay, so here we go. There's x, there's y, there's 0, 1, 2, 3. Now, how big do I need to go on my y? Of my 2 points, which was bigger? Which was my bigger point? It was the second one, 114. So I think what I'll do is I'll go up in 5s, 5, 10, 15. So my first point was, what was it? 0, 8, wasn't it? 0, 8. And my second point was 1, 14. Now, let's graph. What type of point was 0, 8? What do we say it was? Increase in inflection. And what did we say 114 was? Local max. So before I draw it, can you just picture that in your mind, what the graph will look like? You want a rising inflection at 0.8 and a max at 114. Can you visualize before I draw? Let's see if your imagination matches the answer. So I think it's something like this. Rising to a... Oh, that's already ugly. Let's try again. Rising. Oh. It says to show where it crosses the x-axis? You don't need to show. Wow, okay. Then I won't. Oh, that is... Oh, golly. I am going to draw a nice graph here to see if it matches. Execute. Pretty ugly, right? Yes. Let's see. Let's see. Yeah, well, this is an inflection and this is a max. So... let's see what the heck happens. While my program's loading, what's asking us next now in E? Alright, let's draw this here. 24x cubed minus 18x4 plus 8. Fingers crossed. Yeah, not bad. Yeah, okay. Nice. I'm happy. I'm happy. That turned out better than I hoped. Alright, so, you know, that's not so bad. We only have part E left to do. So this is actually an okay section B question. So let's see what's finished this off. A student did 2 calculations. In each case below, explain without doing any further calculations whether the statement is reasonable or not. The value of that is that. Now, there's no calculation. They want to know, do you think that integration is that? So, if you look here, they're integrating from 0 to a half. If you integrate from 0 to a half, then what are you calculating? You're calculating this area. Exactly, that's what they want you to say. So the integration from 0 to a half is equal to the area. Now, how big is this? This is roughly 8 units, and this is roughly half a unit. And I know it's not a rectangle, but it's roughly a rectangle. So it's roughly a half by 8, isn't it? Roughly a half by 8. So the area should be roughly 4, and not... certainly not minus 4 and 21/8. Now, because I was expecting an answer of roughly 4, what do you think the student did wrong? Because their answer was minus 4 and a bit, and I was expecting the answer to be 4. Yeah, I think what happened was the student likely subbed in 0 first, and then minus the half subbed in. In other words, that they did the thing backwards. Now that's an interesting question for 2 marks. So what's very interesting about this B5, which is, in my opinion, a bit unusual, usually they don't, the person who wrote this question is really testing that you understand derivatives and integration, because there's actually not a lot of calculation in this question. You get what I'm saying? Like, it's an understanding question, not a calculating question. And that's a bit unusual for the exam. Okay, lastly, you want to find the tangent, is it? Fine. Okay, let's find the tangent for part 2. The m is dy dx, and what did we say dy dx was? I can't remember. 72x squared minus 72x cubed. And we have to put in x is a half. So that's 72 over 4 minus 72 over 8, which is 72 over 4, which is 18. No, I've gone off by 2. I've gone off by 2. 78, 4. Oh, sorry, 72 over 8, not 4. And 72 over 8 is 9. But I was supposed to get minus 9. Alright, let's check my answer here. Oh, oh yeah, sorry. I'm checking if the student who keeps getting things wrong has got the right answer. So the answer, oh sorry, I didn't even note it. No, don't write this down. Sorry. I'm doing more work than I need to. They don't want the tangent. They want you to know if the student's answer is right or wrong. So is the student's answer right or wrong there? Well, you should be able to tell from my surprise. Is their answer right or wrong?
No.
It's wrong. But how can I say it's wrong without having to do any calculation? You see, they got a tangent of 5 3/8 minus 9x. So they're saying that the m, which is dy dx, is equal to minus 9.
Because it's increasing.
Yeah. At the point half, the dy dx is positive there. Now, I just did the calculation. They got their sign backwards. The student has bad trouble with their signs. So, this is wrong, since from the graph, dy dx is positive. Now,
Should we say dy dx or at x?
yeah, I should be a little bit more precise at x a half.
These things are
They are, aren't they? Okay. Let's see what else. So that was definitely a hard one, wasn't it? What topics are people finding the hardest that they want to practice more? Shall we try and find a hard trig question? I think that's what people might want to. I can see something possibly in version 3 where you were asking me, Angela, about the equations. The trig equations. I think that looks like the best trig one to be doing right now. If you go to version 3, B3, version 3, B3, please. Do you have that? got that? Yeah. Problem with it? What's the problem? Oh, okay. Right. Tell me, do you want to do the A part of the probability, or do you just want to do the trig part? You just want to see the trig part. I think the probability is fine. Let's look at the B part, because it looks a bit hard, doesn't it? Find the angle ABC. So AB, alright, what rule will give me the angle at B? No, I think sine rule. Because you can say, you have the opposite. You could say sine B over 6 root 3 equals sine 45 over 12 root 2. So with a bit of cross multiplying, I get sine B equals 6 root 3 root 2. Sine 45 is 1 over root 2 over 12. So that cancels that, and that goes into that twice. So, of course, you can just do this easily on your calculator. You don't need to be messing about like me. So it's sine inverse root 3 over 2, which is 60. Is it 60? Yeah. Part 2. Part 2. Continue? Yeah. The area of ABC is twice as much as the area of ADC. Find AD. So I think the best thing to do is to look at the area formula for each and say one is twice the other. So for the small triangle, the area is a half AD 6 root 3 sine 30. Yeah? And for the other triangle, it's a half a half 12 over root 2, 6 root 3, and then, did I make a mistake? Please tell me if I did, I can fix it now. Mistake? I know, don't be shy, I make mistakes. No? What's the angle at C? Let me see, it's 45 and 60 is 105, so it has to be 75. Now this angle is twice as big as this one. So if I multiply this by 2, the smaller one by 2, they should be the same. Let's do some cancelling. So 2 multiply a half is gone. A half goes into 12 6 times. 6 root 3 and 6 root 3 cancel. So I get AD is 6 sine 75 over root 2 sine 30. Now sine 30 is a half, so that would be 12 sine 75 over root 2. That's as much as I can do without a calculator. So if you don't mind, please. Huh? So 8.20 meters. The last one is 5 marks. These are the trig equations you're talking about. This one is hard because look at the range. What's the range? Minus 360 to 720. You see that? How many periods is that? Is it, or is it, no, it's 3. Minus 360 to 0, 0 to 360 and 360 to 720. That's 3. Now, normally, how many solutions do you have in one period? 2. 2.
We have one.
2. And if you have 3 periods, that's 6. However, there's a half in there. So, how many is it now? It's getting hard. We're back. Okay. Let me help you out here. 1 period, that corresponds to 2 solutions. 3 periods, that corresponds to 6 solutions. But the half, does that make 3 or 12? Correct. Yeah. 3. Because remember, I said if it was 2, then that makes twice as many. Yeah, so a half would make half the amount. Okay. So there's 3 solutions. 3 solutions. That doesn't seem too bad. It seems a lot better than 12 solutions. I think you agree, right? You'd much rather find 3 than 12 solutions. So let's find the 3. Okay. So tan theta over 2 equals minus 1.6. So theta over 2 equals tan inverse minus 1.6. What's that, please? Minus 57 point. Give us one more digit. 99. Oh, right, 99. 995. Okay, so it really feels like they wanted you to go with minus 58. This really feels like what they want you to pick here. Okay, now, let's use the circle. You know, I used to tell students I really hate this circle, but I'm starting to warm up to it. So, ASTC. Okay, so we have, which quadrant are we in? We're in the one that makes tan negative, and the angle is negative, so we're here. Okay, so how big is this angle? Yeah, you went down 58 degrees, so it's 58 degrees or minus 58 if you want to go down. The second answer for tan, where's the second quadrant tan is negative? Here, isn't it? The one I just drew. Because only here and here could tan be negative. So you draw a straight line over. So if that's 58, that's 58. So the angle we really want is this angle going around here. So that would be 122. But of course you could just use the rule I gave you in class. The rule I gave you in class is to get the second answer for tan, you add 180. So minus 58 plus 180 is indeed 122. So far we have 2 answers. Theta over 2 equals minus 58 or 122 degrees. But we need to make extra answers. So we should add these answers in pairs. So if I add 360 to these, what do I get for the first one? 302 and 482. Okay? What should I do next? Times 2, yeah. Yeah, so that's minus 116, 244, 604. 482, I hope. 800, 964. Now, which are okay and which are bad? Okay or bad? First one. Okay. Second one? Okay. This one too big. If we minus 360, what do we get here? We get, what do we get? Minus 360 from this. 244. Okay? Yeah? It's the same. But that's okay because we said there should only be 3 answers. So I expected to reject one of them. So we don't want that one twice. Now, if I subtract 360 here, I think it's still too big, so I'd have to subtract 360 again. So if I subtract 720 from this, what do I get? 244 again. Oh man. So, do we only have two answers? Oh, sorry. If I subtract 360, is it okay? Oh, sorry. No. No, we're finished now. I'm sorry. Thank you for pointing that out. I thought I was going up to 360. I'm actually could go up to 720. So, in fact, I found my... Oh, so, in fact, I don't need to fix them. I found my three answers. Here they are here. So this fella must be the same as one of these three. What happens if you subtract 360 from 964? Do you get one of these three numbers?
604.
You get the 604, yeah. Okay, so... this is all right for 5 marks. Who was... you were saying you thought you had to find the 6 answers first and then pick. Yeah. Well, if you know that there should be 3 answers and you figure out 3 answers, there's no need to continue searching then. That's why I did this at the start. I wanted to know how many answers I should get. Yeah. Yeah. No, students who make that mistake instantly fail the exam and get sent home on the next flight. For which part? The extra solutions? I don't know. We'd have to check the marking scheme. What type do you want to do next? What do you feel like it? We could do a section 8 question. Look, version 4A6 is another trig equation. Yeah. Version 4A6. Shall we do that one? Another trig one? Yeah. Okay, Stephen. Be awake for this one. Right, 0 to 360. So how many solutions should I have in one period? No, you're asleep now. Try again. 0 to 360. How many solutions? 2 solutions. 2 solutions, right. 2 sine theta plus 80 degrees equals root 3. Okay, so sine theta plus 80 degrees equals, yeah.
Which question was this?
A6 version 4. Okay, if I take my sine inverse of root 3 over 2 is 60 degrees. I hope. Yeah, Ahmed, could you do sine inverse root 3 over 2? Confirm that it's 60, please. Great. Now, what do I do next? I need to make the extra answers. So, do you want to just use the rule or the circle? Your choice. I'm being flexible with you. You can use the rule or the circle. The rule. So the second answer for sine is 180 minus the first answer.
Yeah.
So 180 minus 60 is 120. And then what do I do to finish? I simplify. So I have to subtract 80. So if I subtract 80 from each of these, that's minus 20 and 40, yeah? Well, this guy's okay, but this one needs to be fixed. How can I fix it? Plus 360. So I get to 340 degrees or 40 degrees. There are my two answers. Now that is very, very nice for 5 marks. 5 marks. That is very good. Because there's not a lot to do here for 5 marks. I mean, there's not even 5 lines. There's only 4 lines. 1, 2, 3, 4. So it's like buy 4 marks, get 1 free. Special offer, okay? You see, I thought that would take longer than it did, so we actually have time to do another section A question. What would you find ugly here? Let's see. What do you feel about the question before, the A5 there? You want to do A4? Well, what I mean to say is, do you want to do A5 or not?
Yeah. But that's just a quadrant.
Yeah, so that's why I'm wondering if you want to do something else. What about A7? I think we should do A7. It's 5 marks. It looks a bit hard. A7. Do you see it there?
Yes.
Yeah, will we do that one? Is that a yes? Yeah. Okay. So you have y equals ax squared minus 7x plus b. And you know dy dx is 2ax minus 7. And the x is 2. So that's 4a minus 7. Now that's the slope of the tangent. But you know what the slope of the tangent is. Look at the tangent line. What's its slope? 13. Yeah, 13. So that means 4a is 20. So a is 5. So if I sub that back in, you get y equals 5x squared minus 7x plus b. But what happens if I put x equals 2? What should y equal? If x is 2, what's y? 7, isn't it? If x is 2, y is 7. So if I put in 2, I get 20 minus 14 plus b should equal 7. So 20 minus 14 is 6. 7 minus 6? So b is 1. I apologize if I make these seem too easy. It must be terrible for you. You don't like the trig?
That's what I don't like.
Yeah. The trig's a bit messy, alright. Okie dokie. Got that one? Nah, that seems like a nice picture. Oh, I didn't know the projector wasn't fully down. There's something I want you to do as a homework here. You have here 4 versions of the exam. Version 1, version 2, version 3, version 4. How many section A questions do you have in each? 10. And how many section B questions? 6. So in total there's 40 short questions and 24 long questions. Now I say roughly it should take you 1 minute to do 1 mark. It can take you an extra minute. Like that 5-mark question should take you 5 minutes, but in the exam you can give yourself 1 minute per question extra, so that's 6 minutes. So my rule is, it's the number of marks plus 1. That's the time limit. Can't be going over that. So if you are spending 7 minutes to do that question I just did, that's too long. Okay, so it's a very simple rule. Number of marks plus 1. That's the absolute limit. Maximum. Now, so here you have 10 questions. Each section is 40. Each section is 40 marks, so that means 40 minutes, but plus 1 extra minute per question. So that's 50 minutes. So how long would it take you to do all these section A's? That's 200 minutes. 50, 50, 50, 50. 200 minutes. Now the section B is, they're 20 marks and there's 6 questions. So 6, 120. So that should be 2 hours plus 6 extra minutes. So 2 hours and 6 minutes. 126 times 4, 512. So that's 712 minutes. Ahmed, can you do 712 divided by 60, please? What's that? 11.8 hours. So that's 12 hours. Yeah, but I'm just saying it's very manageable. How much time do you have? You have 2 weeks, this week and next week, right? And then you have the Christmas break. But even if you just take this week and next week, today is Wednesday, isn't it? So what's that? 7. So it's like 10 days, isn't it? Like you have like Wednesday, Thursday, Friday, Saturday, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday. 10 days, including the weekend. And then after the Friday, you have Saturday and Sunday. And then the next week is no school. Okay? So you have 12 days until you're on a Monday where there's no school. So if you spent just 1 hour per day, you'll get all of last year's exams, all of the questions and all the exams covered for 1 hour per day. And after that, you'll be in a very good preparation position for the exam. So I would like you, for your homework tonight, is to set out a schedule for the next 10 days of how you're going to get all these questions done. So maybe you want to do all the section A's first and then move on to the section B's. Or maybe you want to do all the B1s and then all the B2s and all the B3. Okay? But I would like some table to see how you're going to get this all done. Including the questions I already did. I want you to do them again to make sure you can do them. Okay? So this is going to shut down in 8 seconds. No!